Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0235-16, specifically points to a low voltage condition in the turbocharger boost sensor circuit. This DTC indicates that the powertrain control module, PCM, has detected the output voltage from the turbocharger boost sensor is below a predetermined threshold. The turbocharger boost sensor plays a critical role in monitoring the boost pressure of the turbocharger, which significantly influences engine performance and efficiency. If the sensor fails or there is an issue with its circuit, it can lead to suboptimal engine operation, which is why the PCM flags it by storing this code. In this presentation, we will outline the components involved, possible causes of this DTC, the symptoms you may observe, and a step-by-step troubleshooting guide to identify and rectify the problem in the Honda CR-V 2023 and beyond. The turbocharger boost sensor is a vital component located near the turbocharger within the engine bay of the Honda CR-V. Its primary function is to monitor the pressure of the turbocharger boost, which is crucial for optimizing engine performance and fuel efficiency. The data collected by the sensor is sent to the powertrain control module, PCM, which processes this information to manage engine performance effectively. If the voltage output from this sensor drops below a certain level, the PCM recognizes this as a fault, leading to the generation of DTC P0235-16. Therefore, both the sensor and the connections associated with it are critical checkpoints during troubleshooting, since any faults here can directly impact vehicle performance. Several potential factors may cause DTC P0235-16. A faulty turbocharger boost sensor could be the main issue, as it may fail to provide the correct voltage output due to wear or damage. Another possibility is a short in the wiring circuit connecting the sensor to the PCM. A short can disrupt the sensor's output. Conversely, an open wiring circuit can prevent proper voltage from reaching the sensor. Additionally, a malfunctioning PCM may misinterpret the signals or fail to communicate effectively with the sensor, leading to the triggering of this error code. Identifying the exact cause is crucial to ensure effective repairs and restore normal function. When DTC P0235-16 is present, several symptoms may manifest in the Honda CR-V. Drivers may notice a marked decrease in engine performance. The vehicle may feel sluggish or unresponsive as the turbocharger fails to function optimally. Additionally, this issue typically correlates with a reduction in fuel efficiency, as the engine may struggle to operate in its designed parameters. You may also detect unusual sounds from the engine, which indicate abnormal operation. Furthermore, the check engine light will illuminate on the dashboard, alerting the driver to the underlying issue that requires attention. These symptoms collectively signal that something is not quite right within the turbocharging system. The first step in troubleshooting DTC P0235-16 is to turn the vehicle ignition to the on mode without starting the engine. This allows the vehicle's onboard diagnostic system to initialize and read sensor values. Utilizing the HDS or Honda Diagnostic System, you'll want to check the TC turbocharger boost pressure sensor value. If the value reads less than 0.23 volts, this indicates that the sensor is likely malfunctioning or that there is a wider issue in the boost sensor circuit. It's essential to confirm this preliminary reading before proceeding with further inspections, as a low voltage reading is a clear indication of the failure point. In the second troubleshooting step, disconnect the turbocharger boost sensor connector, typically a 3-pin connector. This step is crucial to isolate the sensor from the circuit to ensure accurate testing. Next, Inspect the female terminals of the disconnected connector for any signs of corrosion, damage, or poor contact that could affect sensor performance. Once the connector is clear, turn the ignition on and use a multimeter to check the unit output voltage. Under normal conditions, this should read approximately 5.0 volts. If the voltage reading is normal, then it's likely that the turbocharger boost sensor itself is faulty and requires replacement. If not, further investigation into the circuit is warranted. During the third step, disconnect the PCM connector B, typically a 101-pin connector. Prior to this disconnection, junk the SCS line using the HDS, a procedure that helps to establish a controlled diagnostic environment and reset the system. After disconnecting, inspect the VCC2 and P3 circuits for any wiring issues. An open wire inspection of VCC2 should show less than 1 ohm of resistance. This reading confirms that the power supply circuit is intact. Similarly, for the P3 circuit, a normal reading should indicate more than 1 mega-ohm resistance, ensuring there are no shorts to ground. If any readings fall outside these parameters, a fault exists, necessitating further investigation into the wiring harness and connections. The final troubleshooting step involves a thorough inspection of the PCM itself if previous tests have returned normal results. The PCM is the brain of the vehicle's engine management system, interprets inputs from various sensors, and controls actuators accordingly. If the turbocharger boost sensor and associated circuits appear functional, yet the DTC persists, then the PCM may be at fault. It's essential to verify that any other connected components are functioning correctly and do not show signs of failure, as this will indicate whether the PCM is indeed the source of the problem. If verified as faulty, replacing the PCM is a critical step to restore proper vehicle performance. After completing the necessary repairs, the final verification step is crucial for confirming the effective resolution of DTC P0235-16. Start by clearing all diagnostic trouble codes from the PCM using the HDS. Once cleared, conduct a test drive under various conditions to evaluate the vehicle's performance. Pay close attention to responsiveness and acceleration, as these factors indicate the proper functioning of the turbocharger. After the test drive, reconnect the diagnostic tool to check if any lingering codes reappear. If no codes resurface and the vehicle performs well, repairs can be validated as successful. It's imperative to ensure that all components are analyzed for proper functioning during this phase. To minimize the chances of DTC P0235-16 occurring in the future, preventive maintenance is essential. Regular inspection of the turbocharger boost sensor and its wiring connections is vital to prevent potential failures. Additionally, routinely checking for wear, corrosion, or physical damage can save time and costs connected to repairs down the line. Furthermore, keeping the PCM updated with the latest software ensures optimal performance of the engine management system. Engage in comprehensive maintenance checks to keep the entire turbocharging system operating efficiently. Adopting these preventive measures can significantly reduce the likelihood of sensor-related issues impacting vehicle performance. In conclusion, understanding the function of the turbocharger boost sensor is essential for diagnosing DTC P0235-16. Following a structured troubleshooting approach ensures that technicians can accurately isolate the fault, whether it be with the sensor, wiring, or the PCM. Each step outlined in this guide is designed to facilitate an efficient diagnosis and repair process, while also addressing potential causes and symptoms associated with the error. Additionally, reinforcing preventive maintenance practices can help mitigate future occurrences ensuring that the vehicle remains in optimal condition. By addressing this error code correctly and implementing preventive strategies, vehicle owners can enjoy a smoother and more reliable driving experience. Please like and subscribe to the channel. See you next time.